I've been on mute. Okay. Well. Glad I found that out now. Yeah. So, what I was saying earlier is, you all should be happy that this happened, the whole AOPS situation. Oh my god. The AOPS thing happened during the USEMO and not the USAMO. One of these is much worse than the other. You know? So now, when things go wrong in the USEMO, you guys will be the ones that don't freak out. Alright, so let me get the problems up. Who says ALPS is actually gonna learn? We can find out tomorrow. Like, if it works tomorrow, that means they learn from the mistake, right? And if they don't, then we can freak out. Okay. So I haven't even finished copy editing the solutions, so it'll take me a while before I get them up. I'm probably going to spend a lot of tonight doing some cleanup of the solutions. But okay, so I understand that the tradition is for problem 1 to go for people to try to guess the authors, right? So when things go wrong on the USEMO, when shrug? Yeah, day one's already on. Day one's already on. P1 is already. Was P1 meant to be tricky? P1 is a little tricky. Okay, so problem 1 author. So I never know. What should I put on like the list of candidates? When things go well, I mean it already happened. So Anon, Anghang, Carl, me, Clyde. Every past USEMO author. There's quite a few of those, right? Yeah, I have Carl. Okay, well, we'll just run with this list. So this is problem 1 in author pool. Does USEMO use Jeff rule? Not necessarily. Carl's a lot of votes. Alright. What about other authors? I think that there's enough that like I can't fit them all. Alright. Close. So USEMO 1 is Holden's problem. I don't know if you all know the turtle, but turtle problem appeared. Alright. Yeah. Noise. Oh, I don't actually know if that's this. There's more than one person that goes by turtles of various ships. So did I name reveal Holden? I mentioned that Holden likes turtles, basically. I don't think that identifies his maybe I don't know. All number theory by DJ. Wow, y'all think this is my style of problem? I'm flattered. Nice try. Wrecked. Yeah, it isn't our problem. I wish it was my problem. I do agree it's like the kind of thing that looks like I'd come up with, but this is actually Oncon's problem. F. Okay. Alright. Okay, Twitch chat gets one. Okay. Alright, that's enough clowning around. Let's start the actual math. Okay, welcome everyone to day 1 review for the USEMO. So I'm going to present just 3 of the official solutions and then generally entertain arbitrary questions from the chat. As you see, Holden, Oncon are the authors for today. So, without further ado, so USEMO 1 goes, you have a n by n grid, and you want to maximize cells with the property that they are bigger than their column average but less than the row average. So, depending on like ways that you set this up, there's like various ways that the solution can go. I think the most natural solution goes as follows though. So first of all, what's the construction? Well actually, maybe first of all, what's the answer? Okay, so answer for USEMO 1 is n minus 1 squared. And you get this by doing sort of the obvious thing, which is 1, 1, 1, 1, minus 1, so So you do this thing where the empty cells are 0. And then every cell that's in this little box here is okay. So that's your n minus 1 squared. Okay. Alright, so here, so the way you can get the bound, there's a few ways you can get the bound, okay? Is it intended for a problem 1 to take so long to write up? It depends on what your method is. There's quite a few solutions, actually, or not quite a few. I've seen like 2 very different solutions. One takes forever to write, the other does not take very long. Did I flip the signs? Good point. It should be minus 1. Yes. My bad! Alright, so here's what we're gonna do. Color a cell. We're gonna order the cells by size with ties broken in some way. So all I'm saying is like, there might be some cells with the same number, but you imagine that like you arbitrarily declare that one of them is bigger. And once you do that, fixed way. Once you do that, you can color red let me get this right, smallest number in each column, and color blue the largest number in each row. If you get, probably not. So in this example, these are red, these are blue. And obviously colored cells can't contribute toward the count. Okay, so claim at most one cell is both red and blue. Proof obvious, I think. So if you have 2, let's call these cells purple, alright, just for concreteness. Why is blue red? Oh, I'm sorry. Wait, let's do this. Text BF color blue. Actually, maybe I didn't need the bold. It's okay. Basically what happens is if there's 2 purple cells, then you look at the column and row that contain them, and then things immediately blow up. Okay, great. Wait, was it obvious? No, like actually, if you have, so they're in different rows and columns, and then you look at the intersection, and that cell has to be like both like larger and the how do you say this? Okay, all right. Let me write this. So suppose you have a purple cell here and a purple cell here, all right? And then this is like X and this is Y. Then when you do this, you get, oh, I'm gonna screw this up. P1 greater than, is it Y or X? X greater than P2 greater than Y greater than P1, impossible. Is it? It's not greater than or equal to because I broke the ties arbitrarily. So this is actually important. It's like, if cells are equal, then I arbitrarily decide that one of them will be larger than the other. An equivalent way of saying it is that you can always like fudge the grid a little bit in such a way that the numbers become distinct, but without changing which cells are good or not. I don't think. Yeah, Maximin. So these inequalities are all strict because I broke all the ties. If you want to think about it a different way, you can say like, equivalently, perturb the grid so no entries are equal. And you can do this in a way that doesn't change which cells are good, because any cell that's good is like strictly bigger than its friends. I don't think all of them are strict. Well, like, because of this, there's no equal cells, is the point. Right? Like, it doesn't, like, once you break all the ties arbitrarily, there isn't a notion of equal anymore. Like, cells can't be, wait. Oh, no, sorry, it's the average. Alright, wait. No, it's biggest, right? Each of these is between a max and... Yeah, I'm not comparing the average to anything. This is like between the cells. Okay, alright, I'm just gonna stop here before I confuse myself more. But yeah, this helps a lot, if your entries are all distinct. Man, I'm so impressed that people got Prom 3 actually, because that problem is really hard. I don't think any of the reviewers got problem 3. Or no one reported solving the hexagon problem. Okay, problem 2. So some of you want to use Zig. That's fine if you want to use Zig. But we're not gonna. So first of all, answer 1, 2, 4, 8, 16, 32, as well as 6. Was there a matrix solve for P1? I don't know how the matrix would help you. Like, there's no solution that essentially uses linear algebra, if that's the question. Okay, so what we're going to do is we're going to let n equals 2 to the k times m. And you get some factoring on of the 2 to the n minus 1, and you, because all the factors, let me just write what it comes out to first. So I claim that this is equal to d of 2 to the n minus 1. Because what happens is, by Euclid arguments or whatever, each of the individual factors here is co-prime. I'll overflow the screen. Seto. Come on. Oh, that's a mistake. That shouldn't be there. So 2 to the n minus 1 factors like this. And what happens is they're relatively prime, so the divisor function will factor. Okay, here m is odd. Okay, so okay, wait, hang on. Okay, so here's what we're gonna say. Wait. Oh, okay, here. The right-hand side has k plus 1 factors. So we're gonna do this thing where we're like, okay, if you look at the divisor function, the divisor function typically outputs odd or even numbers. So for almost every value of m, we are going to be kind of screwed, because these numbers are usually not perfect squares. So all of these have a factor of 2 in them. So you get k plus 1 factors of 2, and that like will immediately shoot you down. So that's what's going to happen in 90% of the cases. So I'm just going to quote the following lemma. 2 to the r plus minus 1 is a square if and only if r is in 1 or 3. And so we need at least one of these to be a square, so either m equals 1 or m equals 3 is what happens. Alright, so 2 cases. Case m equals 1. This is the Fermat prime case that you probably did by hand. The thing factors the product of Fermat primes, but as soon as you get 2 to the 5 plus 1 is composite, it splits, and you know, things are great, and you're happy. And in case m equals 3, you compute the first few cases, and then what happens is the numbers will grow too quickly. So 3 times 2 to the o minus 1 is 2. This is 3, this is at least. And then everything after that is not a square and at least 4. Because what? 8 to the square plus... What's the common factor of these things? Hang on. Why? In my notes it says these are all... These are... I just need these numbers to not be prime. Oh, right, because it's a sum of cubes. Yeah, obviously. Okay. It's a sum of cubes, so it's at least 4. And so this forces k to be not very big. In fact, k at most 1, I think. Because you get 2, 3, at least 4, at least 4, at least 4. Here, this is m times 2 to the k, and things will blow up. And this gives the last solution. You think problem 3 is a 40 modes problem? Are you serious? Man, maybe we're just good at Geo. So I did deliberately pick like an easier than usual 2 because I knew that anyone who wants to get that Geo is going to need a lot of time, I think. Maybe some people got it in like an hour because it's just super pro. But I was worried the Geo would be a clean sweep. And I am glad to hear that it sounds like some people think they got it. I think P1 was harder than problem 2. I think problem 1 is harder than problem 2 if you are good at number theory. Like, if you have good number theory instincts, then I think you shouldn't miss problem 2 ever. Well, you shouldn't miss problem 1 either, but problem 2 is like, your experience will help you more. Whereas problem 1, I think, even if you have a lot of experience, it takes a bit to orient yourself and figure out what you want to do. Oh man, Ongkon reused his own problem. Whatever will we do? Alright, cool. Alright, we're done with this. Unfortunately, now we have to do the last problem, which I actually want to see the other solutions people have come up with, because the one I have uses Sondet's theorem. Okay, not when I say the one I have, I mean the one Ongkon submitted, because I couldn't solve it either. Not even close. But let's get a diagram up. Okay, there's your diagram. Everyone who claims solved fake solved, really? That's bad news. Yeah. I don't know. Alright. So here's your lovely diagram with like Euler lines and stuff floating around. As you might expect, H1, H2 is not really that important. It's the Euler line that's really playing, and also the circumcenters. Yeah, that diagram definitely helps you a lot. We're not going to use the whole diagram at once, alright? The diagram, you're going to start though with the following. I want 2 claims. First, the claim is that triangles x1, y1, z1. So, well, okay, the first points I define are the midpoints of the sides. So x1, y1, z1 will be the medial triangle of a1, b1, c1. And similarly for x2, y2, z2. x2, y2, z2 are... First, I claim that these triangles are perspective, meaning that they concur x1, x2, y1, y2, etc. concur at a single point k. The second is that these triangles are orthologic. And that's a term that a lot of you probably haven't heard before, so I'm sorry. This problem was USEMO 3 for a reason, because the solution that we had involves some black magic. So what does orthologic mean? Let me see. So in fact, if we let S1 be the image of G1 under a homothety centered, O2. Centered at G1 with ratio -1/2, then x1, s1, perp y2, z2, etc. Yes, so if you did the USEMO 2 years ago, there was a solution that contestants found, not the reviewers, the contestants found a solution using orthologic stuff. So if you studied past USEMO, congratulations, you're in luck. Okay, but these are the 2 claims. The first claim is that these 2 triangles are perspective, so there's a concurrency point K. The second is that they're orthologic, and the definition of orthologic is that there is a point S1 satisfying these properties. Equivalently, there's some point S2 satisfying the other ditto properties. Thank you, 3VT, for 13 months. Okay, so the first claim is actually quite easy to prove, because what you say is that y1, z1, y2, z2 are cyclic because all of the points are a distance half of side length hexagon from the midpoint of a1, a2. Yeah. No, I think this problem was... I'm glad that some people think they got it, because I was very worried that no one was going to solve it. But yeah, so... What happens is y1, z1, y2, z2 are cyclic, which is great. And then similarly, you get the other things. So if I look at the 9-point circles, so x1, y1, z1, and then x2, y2, z2, either those two circles coincide, which could happen, but if that happens, the problem is actually very easy. The 9-point centers match. Or you get 3 radical axi that concur. So yeah, you look at the radical axi are x1, x2, y1, y2, z1, z2. So great, that's the point K. Okay, so what about the orthologic? The orthologic is actually pretty also easy to see. The hard part is realizing it's important. But the way the orthologic claim works is that because AO2 is perpendicular to B2C2, this is true because A and O2 are both like equidistant from B2C2. That immediately implies X1, S1 perpendicular to B2C2 as well, because X1, S1 is a homothetic image under B2C2. Omcon has a monster config and releases parts of it one at a time. That would be a pretty... That would be one very impressive config, if you could milk it that much, without people noticing. Okay, so, this claim is true, we've gotten those. This is actually the entire proof of the claim, like, there's nothing hidden here. But now the black magic comes and says Sondet's theorem, because of the triangles are both orthologic and perspective, with K being the perspective point, what it implies is that K, S1, and S2 are collinear on a line perpendicular to the radical axis of x1, y1, z1, and x2, y2, z2. So this is a true statement. On the other hand, N1 and N2 are the centers of the circles. So we're going to hold that thought for a minute and try to do one more thing, which is the following claim. So this is the only claim that isn't directly like something that would be a required ingredient of Sondet's theorem. Claim N1, S1, N2, S2, did I get that right? Yeah, is a parallelogram. And the proof is because the vectors over right arrow S1, N2, and over N1, S2 are each equal to 3/2 the vector between the centroids by homotopy. Am I blocking the claim? I'm blocking the claim. A is not a point. Maybe A1? Probably. Yes. So the 9-point centers relation to the S is actually that N1, N2 is parallel to S1, S2. No, wait. Sorry. N1, N2, and S1, S2 have the same midpoint. On the other hand, when the radical axis of x1, y1, z1 is in turn perpendicular to, so that radical axis is perpendicular to N1, N2. So S1, S2, and N1, N2 are parallel and share the same midpoint. So therefore, we now have this orange line that ties all the points that we constructed together. So N1, N2, S1, S2, K are all collinear on an orange line. Okay, and because the 9-point things are, hang on. Let me get this right. So by homothety from G1, N1, S1, this orange line is parallel to O1, O2, once I have just these two. Okay, so conclusion, O1, O2 is parallel to N1, N2. And that's a wrap. I don't know how much of that made any sense. Because this problem is freaking cool. Yeah, so later tonight I'm going to clean up the official solutions and post them on the thread. Maybe like in a few hours. But yeah, this is kind of a lot. Mostly because I think most people are not used to orthologic triangles, and probably even fewer people know what Sondet's theorem stated. Yeah. I think we broadly thought that this problem was probably too hard to propose to the IMO, so that's why it's on the USEMO instead for you kids. The solution by... oh, I want to see the solution. Wait. This is behind, right? Okay, wait. Ah! There's too many of these topics. This one was first. Because this one says 36 and this was 35. Okay, what does this reflect? What? Okay, A2 over B1, C1. Oh, okay, uncomposed anyways. Okay, great! Great, there's a solution not using Sondet. Nice! Thank you, kids. Do you think learning geometry through random XX century modern geometry is helpful? So I don't actually know which books you are referring to, actually. Yeah. I don't know, because basically none of the reviewers solved it or found a different solution, and then Oncon's solution uses Sondet's theorem. So we're like, if our only solution uses Sondet's theorem, we can't really send this to the IMO, right? Like that's out of IMO syllabus. So we put it here instead, and it looks like there's a different theorem or a different solution. Merge them with mod powers. So sadly, merge isn't a mod power. That was on the very old forums a long time ago. We're gonna need a lot of problem 1 graders. What's Mo's a meme? Yeah, sounds about right. Did you get too many problem ones this time? Uh, I'm not commenting on the packet until tomorrow. I don't want to leak anything about day 2. Wait, I thought the actual Mose is like literally a last name. Yeah, okay. What do you think the Mo's are? I'll have a better sense after the grading. I kind of feel like it's sort of like a 15-15-50 kind of, but I might be wrong about that. I feel like I have a hard time judging like 1 and 2 because they're the problems that they're the kind of problems that I'm good at, but I know that not all the students are good at. So even if they're easy for me, it doesn't help me much. Because both problems, like USEMO 1 is like a problem that's like figure out, like write down some structure, like you color some cells or whatever, and USEMO 2 is like Baroque number theory, and both of those are like my strong suits relative to other Olympiad stuff. So those are the ones I actually have the hardest time calling because they all feel like easier to me than I know they will be. 2018A. Which one is 2018A? Oh, sorry. I use like Baroque and classical interchangeably. I just mean like classical, like traditional. Divisors of a to the n-1 type things. I think problem 1 is a problem that requires a lot of mathematical maturity relative to its difficulty. That's the other thing. Like, if you are used to, like, if you have, like, a lot of experience writing proofs, then you kind of know what's going on. If you don't have much experience writing proofs, it's not the kind of problem that you want to start with. I think it's gettable, but you'll need to spend a lot of time asking yourself, like, what is the definition that I'm trying to write down? Because at first you don't know how to define things, right? Because, like, for example, that problem has a step where you say, like, at least in my solution, I, like, order the cells breaking ties arbitrarily. And, I can write that because I know what I'm doing. But if you don't have that much experience, you don't know to write that or how to write it either. What do you think Mo's are on this year's IMO? Weird. I actually thought both problem 1 and 4 were really hard for their positions for the IMO. In particular, I tried IMO 4 on the stream and like did not get it cleanly. I got a lot of help from the audience for IMO 4. And IMO 1, I did not find a short solution. I was doing a zigzag thing, and then someone later told me, by the way, you can just find a triangle, and then I was really upset. Because I was like, seriously? Use Hall. Yeah, there's a solution to USEMO 1 using, like, Hall's marriage lemma, or its contrapositive, or whatever. So, I guess that can happen. Yeah. Oh, what is that thread? Oh, it's just a troll post, okay. Let's move on to P4, nice try. I still have nightmares sometimes that like I'm doing a review for like TSTST or something, and then like I accidentally review day 2 because I forgot the order of the days in my head. How to get better at Baroque NT? I don't know. Do the... I guess you already did X-NT and Heavy NT units. Man, moving points. Did I see the suggestion? Yeah, I decided it was probably not worth it. But I appreciate the suggestion. Alright, do people want to stick around for games or nah? I'm probably going to do at least one game night either tonight or tomorrow. But I'm having trouble deciding which day. I have a sponsor game I need to play because I haven't... It's been a while since I got the Steam key. Play the game where you reveal all the diamond codes? No. Wait, okay. There's 2 that no one's gotten yet, right? I think I know which 2. One of them I can see why no one's gotten, although I still think it's fair. The other one I'm surprised no one has managed to get. But... Oh, there's only 1 now? Ah! Hey! Oh, you got it. Yeah, okay. I'm actually surprised that one took so long to show up, but now it's there. Yeah, the last one will... Your hint for the last diamond that no one's gotten yet is that... I think you should suspect the diamond is there. Like, I think you should know... I think you should be able to, like... be looking in the right place without any further without knowing anything else. But to actually get there requires some effort. I think it's a thing where if you've been paying a lot of attention, you should think, I found like diamonds in X and Y, so there should probably be a diamond in Z as well. But now I need to figure out how to get to Z. So it's that kind of situation. Yeah, okay. What was the solution for problem 2? So there's multiple solutions. The clean solution that doesn't use any weaponry is to basically write this factorization and then realize that these divisor functions are usually even numbers. And there's k plus 1 of them. So almost certainly there's too many factors of 2 on the right hand side. And there's only a few edge cases for which there's only a few edge cases for which you can get it otherwise. Because you need these to be squares for the divisor function to spit out an odd number. And powers of 2 plus minus 1 are almost never squares. Oh my god. people got the sock puppet. Oh, okay. I'm surprised it took that long. I was expecting that one to get snapped up really quickly. What are your recommendations for learning algebra? Like Olympiad algebra or abstract algebra? How do you factor 2 to the 32 plus 1? You search for primes that are 1 mod 64 and 641 works. I think definitely for that problem, we'll just let you quote without proof that 2 to the 32 plus 1 is not prime. Although, if I was a contestant on the USEMO, I would probably verify it manually just to be safe. If I was the grader, I would kind of be like, I don't really want to penalize people for this because it's obvious that you need to do this. It's kind of clear what you're supposed to do. There isn't a good way to do it by hand, and it's like extremely well known. So if I was the problem captain, I would probably be like, you just let it go. I don't think this is the place where we want to be like, write this out because people know that 641 divides it, and so it's just because it's so well known and also so obnoxious to do by hand. If I was the problem captain, I'd just let it go. But if I was the student, I would probably write it out anyways. Because if I know 641 is the prime factor, that makes it really easy to do the division. Well, they're very easy, so maybe a bit of an over. But it's because like 65536, you then take a mod 641, and it gives you like 154. So then you only need to do 154 squared plus 1 is 0 mod 641 or whatever. 2 to the blah plus 1 is x squared. I think that's up to the problem captain. If I'm the problem captain, which I won't be, I would probably let it go. If it was the USEMO, you should probably write at least something. Like at least quote Zygmundi or something. Or like Cadillac conjecture. Yeah. Yeah. All right. Okay, actually, I'm kind of hungry, so I'm going to make the executive decision that games night is tomorrow night. In part because probably some of you would want to get your rest before day 2, which will also be great. Hope you like the problems! Man, USEMO problems are so good. I'm really happy with the 6 that we got. Alright. Can we solve Catalan conjecture using only Olympiad math? I don't think so. It's 8 AM and I haven't slept yet? Oh yeah, then you should definitely sleep. Yeah, alright. Get your sleep before day 2 or, I don't know, otherwise relax. Meme in the Discord, etc. Yep, alright. See you all.